Alright, welcome to the video. We're going to work a little bit on 4.2. And to begin with, when you look at the warm-up, this is just a review of solving equations. So some of them are quadratic, some of them are linear. And you're just going to want to solve for x, meaning get it alone on one side. For the linear equations, all you have to do is use addition, subtraction, multiplication, division. When you do the quadratic equations, like problem 2, after you get x squared alone, you'll have to square root both sides. And remember, when you do that, you get a plus or minus in your answer. Alright, this lesson is substantially shorter than the permutation lesson because all we're going to talk about today is combinations. Remember, in permutations, order mattered. In other words, ABC was different than BAC. Those were two different permutations. But, so in problem 9, for permutations, order matters. ABC is different than BAC. But today we're going to talk about combinations, which just means groups of things. We don't care what order they're in. So if we were talking about combinations, the combination of ABC and BAC, they're exactly the same thing. Both combinations contain the same three elements, A, B, and C, regardless of the order they're in. So for combinations, order simply does not matter. So let's look at the definition of combinations. It's really similar to the definition for permutations in terms of its equation. You'll notice the only difference here is instead of just being n factorial divided by n minus r factorial, we have to divide by r factorial again. The notation we use is NCR. N stands for the number of things, and R stands for how many you're taking at a time. So let's try an example here. Someone says find the number of combinations of 2 objects you can take from a group of 5 objects. So notice everywhere there was an n in the formula, I've put in a 5 there in its place. And everywhere there was an r, I put a 2. And when you simplify that out, you find there's only 10 different combinations of 5 objects taken 2 at a time. How many ways can you select 3 novels from a list of 10? Well, same thing, that's 10C3. And you can use your calculator to do this, similar to the way we found permutations. Hit the math key, then go and select the probability menu, and the third option down is NCR. And then all you have to do is type in 10 and 3 in the blanks provided, hit enter, and you'll get your solution. We're going to be using the cards a lot as we discuss probabilities, so I've included a little table here. There's 52 playing cards in a standard deck. It has 4 suits: spades, hearts, diamonds, clubs. And there's 13 different cards, ace through king, in every suit. So these are all the possible cards or possible outcomes there are when you draw a card out of a standard deck. Well, how many different ways could you give somebody a 5-card hand out of this standard deck? Well, we don't care what order those cards are in when they're given to us, correct? If someone gives us 5 cards, it doesn't matter how we place them in our hand. They're the same 5 cards. So this is a combination. And the way I got this number, 2,598,960, is to calculate 52C5, 52 objects taken 5 at a time. Same with how many 2-card hands are possible. 52 cards taken 2 at a time, 52C2, and if you calculate that out, 1,326 possible 2-card hands you can be dealt. This is where it gets a little bit more difficult. Sometimes you have to use combinations along with the fundamental counting principle, and this happens when you have 2 events. Event A and event B can occur. So in that case, we have to multiply 2 different combinations together. Just like when we had 2 choices before, we had to multiply all the choices from the first event times all the choices of the second event. So let's look at problem 19. And how many of the possible 5-card hands that you could be dealt are all the cards from the same suit, meaning they're either all spades or all diamonds, all hearts. So what we got to do is look at this in a series of 2 choices. Their first choice is how many suits are there? So there's 4 possible suits you could choose from. And how many of those suits are you going to use to get 5 cards of the same suit? Well, just one of those suits. How many cards are in a suit? Well, 13. And how many are you choosing at a time? 5 of those, because we're going to have a 5-card hand. So in the first choice, we have 4 C1 possibilities. And for the second choice, we have 13 C5 possibilities. And when you calculate that out, that's 4 times 1,287 for a total of 5,148 possibilities. Let's try an example of this. You visit an omelet stand. They offer 6 veggie ingredients and 4 meat ingredients. And you want only 2 of those veggie ingredients and 1 meat ingredient. Well, your first choice is which veggie combinations could you have? Well, there's 6 total veggie combinations. You want to choose 2 of them at a time. And for choice 2, there's 4 meat combinations. You only want 1. So 4C1. Fundamental counting principle says number of choices in the first event times the number of choices in the second gives you the total. And that's where we get 60 possible ways that you can get an omelet with 2 veggie ingredients and 1 meat. When you're trying to figure out the number of ways that an event A or an event B can occur, or is a very different word than and, we add up all the possibilities. So let's go back to the omelet stand, but this time let's say we don't care if they're veggie or meat ingredients, we just want at most 3 ingredients. In other words, we could choose 0, 1, 2, or 3 ingredients, any one of those options. How many different types of omelets could we order? Well, we have to figure out how many different ways we could order 0 ingredients, 1 ingredient, 2 ingredients, and 3 ingredients. And when we have each of those individual amounts, we add them up to get the total possibilities, in this case 176. Let's look at a second example. If you're at a theater and they're putting on 6 plays, you want to see at least 2 of them, meaning you're going to see either 2, 3, 4, 5, or 6 of them. Well, in that case, you could say 6C2 plus 6C3 plus 6C4 plus 6C5 plus 6C6. And when you find those combinations and add them together, you'll find there's 57 different ways that you could do that. All right, let's do a few examples from the practice together. I'm not going to do any from 26 to 33. Just use the formula that is in the notes above to calculate the number of combinations from in problems 26 to 29. I think your packet says permutations right here. That's a typo. It should be combinations. And then use your calculator to do the second part. But let's take a look at one of these problems down here from 34 to 38, because these are a little more challenging. Let's take a look at problem 35. We're asked to find how many ways we could get 4 aces and 1 other card. How many combinations of that hand could we get? Well, 4 aces, there's only 4 aces in the stack. So of the 4 aces, if we're going to choose 4 of them, we have to choose all of them, 4C4. And I have to times, because there's actually 2 events here, the event of getting 4 aces and the event of getting 1 other card. Well, we've already taken out the 4 aces. There's now only 48 cards left in the deck. And of those, we only want to pick 1 more. So 4C4, all right, times 48C1. This is just 1 times 48, and that's where the solution of 48 other cards come from. I leave the solutions here on this page again because these problems are particularly challenging, and I would like you to show the work of how you get this number. I don't mind you having this solution. To get this point, I'm going to want to see that, to show me that you understand where that came from. All right, for these next 4 problems, you have to actually decide, am I going to use a combination or a permutation? And the way you decide that is if order matters. So if you look at problem 41, 8 members of a school marching band are auditioning for 3 drum major positions. We don't care what major position they end up in. Any of those 3 is a major position. So in this case, we're going to say this is a combination. Okay. Oops. I fix my pens here. It's a combination. And so it's just going to be 8C3, which is 56 different possibilities. All right, and as you go down through the rest of those, you're deciding, is that a permutation or a combination? A little hint on 42. You're used to seeing somebody say first, second, third, fourth to mean order. Well, if there's positions like editor and assistant, that's also a way of expressing order, because once someone's been selected for editor, then getting selected for assistant, you can't be the same person anymore. All right, so you're saying editor's like number 1 position, assistant's like number 2 position. So it is like saying first, second, and third place it's still a situation where order matters. All right, good luck. If you have any questions, come see me outside class time. I'd be happy to help you if you need additional assistance. Remember, if you need to grade this homework also, you need to do that either after school or during target time on Mondays. Thanks.